Okay, this will be the last lesson for the week. This is 11.7 that I actually planned for you to do on Friday, due for Monday next week, but I'm just going to roll them all out so people can pace themselves. Some people want to go a little quicker. So in chapter 11, lesson 7, we're going to divide polynomials, and we're going to use some long division. I've said this is one of my favorite lessons of the year. Can't tell you why, but I think this is rather fun. So you're going to get a polynomial, and you're going to be also dividing it by a polynomial. When I say polynomial, if you look at this expression, there are 3 terms, 1, 2, 3, so this is called a trinomial. You're dividing in example 1, a trinomial, by a monomial. So if you look up here, this breaks this up into sections, but to divide a polynomial by a binomial, so you have to look at when am I doing what? Polynomial by binomial. Then you can use the method I'm going to show you right now, which is to divide each term by the monomial. That literally means 9x squared divided by 3x, the positive 12x, divided by 3x, and the negative 18 divided by the 3x. Okay, each separate terms are expressions that are added together. This can be written as plus a negative. Then you pretty much just simplify each of the expressions. So if I had 9x squared and I divide by 3x, 9 divided by 3 is 3. Exponent rules, x squared divided by x is x. 12x, everything's positive, divided by 3x, 12 divided by 3 is 4, positive 4. X over x, or x divided by x, will cancel itself off. Minus, so this is a negative. 18 divided by 3 is 6. But then that x is going to stay in the denominator. The answer to this looks a little funky with the minus 6 over x, but we are going to leave it that way. So that is your solution if you divide 9x squared plus 12x minus 18 by 3x. Okay, so you can only use this method. What I just showed here, this is not long division. This method only when there's a monomial. Monomial meaning there's no plus or minus sign in that 3x. This is the monomial that they're talking about. Okay, the only time you can use this method, example 1, is dividing a polynomial by a monomial, which you don't see a plus or minus sign. Okay, example 2. We are going to venture into long division. I'm going to show you example 3. See that that's a polynomial, and this time divided by a different polynomial. There's an addition sign here. So we're going to use long division to do example 3, but before we do example 3, I just want to revisit long division. So I'm going to write 453 divided by 18. Okay, remember whatever this is your number on the inside and you are dividing by 18, that ends up on the outside of the bracket. Okay, so you first ask yourself how many 18s, maybe you ask yourself how many 18s go into 4, none. So move a number over, 18 into 45. How many 18s go into 45? And that would be 2. So you put the number 2 above the 5 in 45. 18 times 2 is 36. And then you subtract. We're going to just bring this 3 down. And 45 minus 36 is 9. And then ask yourself how many 18s fit into 93. That should be 5. You can use a calculator for that. And 18 times 5 is 90. And you subtract. and you get 3. At this point, I don't want you to add any zeros. I don't want you to add any decimals. I've shown you this before. I guess old school, when you were little, you called that a remainder. I want you to take your remainder and put it on top of your divisor. So it would be 3 over 18. In other words, my final answer would be 25, and then if I reduce 3/18, finding a common factor, I get 25 and 1/6. That's an exact answer. But I'm going to use that process, that long division process that I just ran through, to divide 3x squared plus 7x minus 12 by x plus 3. Okay, so the x plus 3 is going on the outside. And the 3x squared plus 7x minus 12 on the inside. Okay, when you are dividing by a binomial, you really only work, to begin with, when you ask yourself how many times this goes into something, you are only looking at the first term in the binomial, trinomial, whatever you're working with. Okay, so x. Same goes for the trinomial on the inside. You are looking for, I'm just going to write it over here, x times what equals, and I'm just going to say the 3x squared part. Okay, so this x times what gives you 3x squared. I'm going to tell you that that is 3x. Okay, so your answer to this question went right there. Once you figure out that piece of information, so again, first term, what number, or letter in some cases, x times what equals this first term. X times what makes 3x squared? 3x. Then you're going to take the answer that you wrote on the top and multiply it, like the distributive property, by each of these terms. So 3x times x is 3x squared. 3x times 3 is a positive 9x. Then, just like you did in the long division problem, you're going to subtract. Okay, so therefore, you're doing this intentionally. 3x squared minus 3x squared is going to be nothing. 7x minus 9x will leave me with a negative 2x, and I can bring down this minus 12. Go back out to that highlighted x. Ask yourself this same question, except for this time it's x times what to give you this negative 2x. Okay, x times what gives you negative 2x? Negative 2. And then you take the negative 2 and multiply it by each of these, just like you did with the 3x. Negative 2 times x. Negative 2 times 3. Careful with all your subtraction signs when you subtract. A negative 2x minus a negative 2x is like adding 2x, so that becomes 0. Negative 12 minus a negative 6, which is like adding 6. Negative 12 plus 6 is a negative 6. Remember on this long division problem how you just took what your remainder was and put it on top of what you were dividing by? You're going to do that very same thing. You're going to take this negative 6. You can make it as like a minus sign if you want. And put it on top of the x plus 3, what you were dividing by. And then that's your answer. Yeehaw. Okay. Example 4. Example 4 and example 5 are a little different than example 3, but we're going to use the exact same process. We just don't have a trinomial on the problem right here. Notice that it has n squared, but there's no middle term like an n in the middle. So we're going to put a, I guess, a placeholder into the problem. You're going to write the 5n squared. There we go. We're going to write the 5n squared. But we're going to take these exponents and kind of run them all the way down. So we do want an n to the first power. So I'm going to write plus, this is 0, n. Meaning if no matter what n is, this is really nothing. It's a placeholder, but it doesn't have a value. The value is 0. And then plus 2 on the end. It'll make sense why I added this 0 times n in the middle, to have something to subtract from when I do the problem. All right, step process again. When you're dividing, you will ask yourself, n times what makes the 5n squared? So times 5 and times another n. Do you agree that n times 5n makes 5n squared? Okay, so then you're going to take the 5n and you're going to multiply it by each of those terms. You'll get that 5n squared, and then 5n times 1 will be a positive 5n, and I need to subtract. Now you can see why that placeholder is there, because this is nothing, this is 0, but I'm going to subtract 5n's from it. Okay, so 5n squared minus 5n squared, nothing. 0 minus 5n, a negative 5n. And then 2 minus, if you want, nothing, is a positive 2. Okay, back out. N times what makes negative 5n? So n times what to give you this negative 5n? That will be a negative 5. You're going to multiply it by each of those two terms. You don't have to draw the arrows in your work. I'm just explaining this. So negative 5 times n, negative 5n. Negative 5 times 1, negative 5. Subtract. Negative 5n minus a negative 5n is like adding, so this will become 0. This also will be like adding. 2 minus a negative 5 is 2 plus 5, and be a positive 7. Once you get down to that very last number, your 7 is like your remainder. This is a positive 7, so you can write a plus sign and put your 7 on top of what we were dividing by, which was the n plus 1. So your answer is right there. Fun stuff. Okay, one more example. As you can see, it's really pretty much doing the same thing over again. Just analyze your problem before you start. So if I have m squared minus 16 minus 21, it's going to go inside. But what you're dividing by, you want it from highest exponent down to lowest. So I'm going to switch this around to 2m plus 4. Okay, so put your variable out in the front. All I did was switch the order of this. So on example 5, you might have to switch the order, make sure the variable's out in the front. On this one, I added a placeholder. a 0 n in the middle. All right, my high-level mathematicians. 2m times what is going to give you 1m squared? 2 times what makes 1? 1/2. Okay, so 2 times 1/2 makes 1. M times another m will make this m squared. So you're going to have to use your thinkers. 1/2 m times 2m gave me that 1m squared. I'm subtracting. So right now I multiplied this times this. I also have to multiply it by 4. So 1/2 times 4 is 2. And I have to multiply it by plus 2m. One m squared minus 1m squared is 0. Negative 16m minus 2 more m's is negative 18m. Bring down your negative 21. It'll get easier from here. So 2m times what is going to make negative 16m. I'm sorry, 18. So that should be a negative 9. Negative 9 times 2n is negative 18m. Negative 9 times 4 is a negative 36. We're subtracting. So your negative 18m minus a negative, which is adding 18m, will be 0. Negative 21 plus 36, because you're subtracting a negative. So negative 21 plus 36 is 15. And you take that positive 15 and write it on top of the 2m plus 4. All right, those are all the examples for Chapter 11. Your assignment for this lesson is page 687, 15 to 49 odd. There are extra examples in your book. Have at it. Send me some questions. Bye.